I was content with not having Algebra 1, just for the record, for the rest of the year. But then Andelin's mom sent me a message about how she hasn't been able to sleep for 2 weeks. And all she thinks about are variables and numbers and exponents. And so I said, look, I'll do what I can to help out. And so we're going to have math class again. And I want you guys to make sure that you take good notes. Okay, I always want you to take good notes, but I hope, as you've already read in your instructions that were sent out, that you can use your notes on your test. We don't normally do that. Now, we have some challenging circumstances right now, so make sure that you take really, really good notes, okay, and you can use those on your test. You cannot use your books on your test. So you can use your books to take notes. You can use what I teach you, especially what you're going to find on the board, and you can use those on the test, and I think they'll be really helpful to you. You're not going to be seeing me. If you've already watched the Bible video, you know why, and if not, watch the Bible video and you'll figure out why. The focus is going to be on the board so that you can hopefully see it clearly. And what we're doing this chapter is building on what we did in chapter 9, which was dealing with polynomials. And what we're going to be doing is a whole lot of factoring, okay? And it's going to get more complicated with polynomials, but we're going to start with just some common monomials. And you can find this in section 1 and chapter 10 of your book if you'd like to follow along. And actually, I really do want you to do that. Get your book if you haven't already. Okay, and if I get to going too fast, remember, you can hit pause on the video. This is not live. You can hit pause on the video and you can quickly catch up. What we're going to do is I'm not going to go through and really just per se reteach everything from the ground up in section 1. We actually had that in the Monday before we left to be away for a couple of weeks. And so I'm not going to give all the just basic ground level background to that. We've already done that. But what I do want to do is not move on from section 1 in this class period, because since it's been 2 weeks, I do want to review what we discussed so that we'll be on the same page as we do move forward. So I'm on page 406, and these numbers that you see correspond on that page with the exact numbers. And I encourage you to do these with me. If you want, feel free to pause the video and work ahead and then watch the rest of the video and see how things transpire. And if you got them right, that all works just fine. But let's do number 1 together. We're factoring common monomials. And remember, what factor tells you is multiplication. And so two things are being multiplied together, okay, as factors to produce a product. And so what we're going to create from two numbers are things that can be multiplied together in the end. That's eventually what we're going to do. But actually, for these first 6, all we're going to be doing is finding, you remember this? The GCF. GCF. Greatest common factor. Okay? And there are 2 ways, you might recall, if you were a part of the class 2 weeks ago. I think the only person who was missing was Parker. But there are 2 ways of doing this, and it's going to be basic enough we can catch up, okay, even if we weren't in that class period. Parker, how you doing, buddy? But let's go through this quickly. Greatest common factor, okay? There are 2 ways of doing this. We can just make a factor tree. All right, that's kind of the classic way of going about it. You can make a factor tree of 45 by finding 2 numbers that when multiplied together give you 45. And here's where your multiplication table comes in really handy. And remember, the bigger the numbers you use, the quicker that helps you to get to your desired destination. And so what are 2 factors that when multiplied together get you 45? Well, probably what comes to our minds are the numbers 9 and 5. And I put the dot between not as a decimal, but as a multiplication symbol. 9 times 5 gets you 45. But we have to continue to break these numbers down until all the numbers that are left are prime, meaning they can only be multiplied by themselves and 1, and there are no other multiples that you can break them down further into. Okay, 5. Is there anything other than 1 and 5 into which you can break that down to a lower number? No, correct? You can't do that. So you just bring down 5. It is prime of itself. What about 9? Are there any other factors other than 1 and 9 that can be multiplied together to get you to that very number 9? And the answer is yes. You can do that. You can multiply together 3 and 3 to get you to 9. And look, 3 times 3 is 9, and times 5 is 45. And so that's breaking it down into its most basic prime factors. Now, to find the greatest common factor between two terms, which in this case are easy because they're numbers, we have to do the other number just like we did that one. All right, let's break 75 down as much as we can. I look at this number and I think, well, because it ends in a 5, like 45, I know that 5 will go into it. And if you divide 5 into 75, with what do you come up? 5 will go into 7 one time. Bring down your 2. Bring down your 5, 25. How many times does 5 go into 25? 5 times. So your two factors are 5 and 15. Now we already know that you can't break down 5 any further. It's prime of itself, and so we'll leave that. However, how can you break down 15 until you have two prime factors of that number? You can do that with your multiplication chart, the numbers 5 and 3. Because 5 times 3 is 15. 5 times 3 is 15, and then look across to your left. 15 times 5 is in fact 75. Now, the way I find the greatest common factor is I look at what numbers are shared in common, and they have to be shared in common the same number of times to use that number of times. And I see 2 3s here, but I only see 1 3 for this number. So I can use 1 3 from each number. I look at my 5s. I have 1 5 here, I have 2 5s over here, but I can only use one of those 5s because that's all that they share in common. And so what I'm going to have in common between the two are 3 and 5. What is 3 times 5? 3 times 5 is 15. Therefore, the greatest common factor of these two numbers is the number 15. Now that's the harder, longer way of doing it. I showed you when we were together, hey, let's do the shortcut if we can do it. God's given us a brilliant mental calculator called a melon on top of our shoulders, and let's use that, and let's use our understanding of the multiplication table to do it in an easier way. The easier way is this. When I look at these two numbers, 45 and 75, what's the largest number I know that will go into each of those? And I can do a little bit of experimenting if I need to. I look at 45 and I know 15 will go into that 3 times. Okay? I look at 75 and I know that 15 will go into that. Now I might have to do a little bit of calculation in my head, but I can do it or do a little bit of quick division and find that 15 will go into 75 5 times, so 15 goes evenly into both numbers, and the leftovers are 3 and 5 when 15 is divided into each respectively. And so just by looking at it, I can say that the greatest number that they have in common, leaving only prime factors, is 15. And man, that's a lot faster than doing all that factor tree stuff, isn't it? So let's try that from here on. And let's do that with number 2. Okay, the numbers 33 and 51. What's an obvious number that will go into 33? An obvious number. You could say either 11 or 3. Well, you can just look at this and know that 11 doesn't go into it because 5 times 11 is 55. They wouldn't have that in common. But you can look at that and say, well, I know 3 would go into it, and 3 would leave you with 11. Okay? 3 and 11. 3 times 11 gets you to 33, but I divided by 3 to get me 11. Can I divide 51 by 3? Well, let's try it. All right, if I were to use 3, okay, how many times does 3 go into 5? Once. With a remainder of 2, bring down my 1. How many times does 3 go into 21? 7 times, and so my number is 17. Look, 11's a prime number, 17's a prime number, but by what did I divide each to get the factor of these prime numbers? 3. And so my greatest common factor is 3. And you see, I did a sort of factor tree there, but it's a little quicker one that I'm doing in my head. And I know you guys can do it too, because we did it a couple of weeks ago in class. Now, how do I handle this whenever I get variables involved? Well, the first thing I have to do is just ignore the letters, okay, and just look at the numbers. 24 and 32. What does 24 and 32 have in common? The largest number. Well, I know something like 2 is going to work, all right? But let's go bigger than that. How about 8? How about the number 8? All right, 8 goes into 24, and 8 goes into 32. And when you divide each of those by 8, you would end up with 3 and 4 respectively, right? But we don't have to do that. We're just finding the greatest common factor. Well, the greatest number they have in common is 8. But guys, don't forget about the variables in a term. What variables do they have in common? That one has a y, but this one doesn't, so that's not common. This one has an x, guess what? That one has an x also. And that's x to the first power, that's x to the first power, so it's x to the first power, which we don't write that exponent, but we understand it, that they have in common. Now, if you get larger exponents they have in common, you do the largest exponent, but that both of them do have in common. And you'll see that as we move along. How about this one? This is a little bit different. Number 4. Let's look at the numbers in these two terms. We have numbers now and variables. What's the largest number they have in common? 7. Is there any way, that's a prime number by the way, is there any way you can use 7 to get to 15? No, you cannot. So there's no number they have in common. Alright, what variables do they have in common? This one has an x. That one doesn't have an x. This one has a z squared. This one has no z at all. This one has a y. This one doesn't have a y. Guys, what does that have in common? What do these two numbers have in common? Nothing. And therefore, the commonality is these are prime numbers. Keep your eyes peeled for that. Not all of them are going to have numbers and or letters in common. Well, let's see about this one. And number 5. X squared y cubed and x cubed y squared. Okay, don't give up. Just take a minute and look at it. This one has an x squared. This one has an x cubed. Well, they both have x's, and so they have something in common. But what's the largest exponent that they have in common? This one's a squared, that one's a cubed. This one only has 2. This one has at least 2 and one more than that. And so what they have in common is x squared. Now I don't just take the largest exponent between the two, but I take the largest exponent that they have in common. This x squared is also found here, but there's another x, and that's to the first power. I can only take the greatest of what's common between the two. Okay, what about y? I have a y here, it's cubed, and I have a y squared there. Well, I have y's in both, so I can use y. To what power do they have in common? This one has a y to the third power. This one only has a y to the second power. I want to use the largest power I can, but they have to have it in common. I'd love to go y cubed, but I can't go that high because that one only has y to the second power, or y squared. So my greatest common factor is x squared, y squared. Okay, how about number 6? Let's deal with numbers first in a term that has both numbers that are expressed as well as variables. So I have 4 and I have 10. Alright, so What do they have in common? First thing I like to ask myself is, can 4 go evenly into 10? Of course the answer is no, it can. It can only do 8 or 12 evenly, but it can't do 10. So it can't be 4 that's in common as a number. However, you might notice that they're both even numbers. And since they're both even numbers, we do know that what number can go into both of them? That's right, 2 will go into 4, 2 will also go into 10. And it will leave 2 and 5, which are prime numbers, and that's exactly what we want. Alright, now let's take a look, now that we've figured out the numbers, or number, let's take a look at the variables. This one has an A, that one has an A. So we know that A will work, but A to what power? What do they have in common? This is understood as A to the first, even though we don't typically write it. A to the first, A squared. I want to take the greatest power, but it has to be what they share in common. And there's only one of them that's found here, so I can't go any higher than that, and I leave it as A to the first power. Alright, I have a B here and I have a B there. But to what power is the greatest commonality? This one's B squared. That one's B understood to the first power. I want to go the largest I can, but they have to be in common. And the largest in common is only an exponent of 1. This one has one more above that. I can only use 1 because that's all that that one has. That's what they have in common. Okay, now I'm going to take a little break. Now these videos this is all going to be spliced into one video, but I don't have much space, as you can tell. And so there will be some splice moments. So if I end the video over here and all of a sudden I'm right here, don't get freaked out if it's that way. But I'll be right back and we'll do some more here in just a minute. Alright guys, I'm back. So we're going to take this information about finding the greatest common factor, alright, and we're going to actually factor expressions from that. And so when I look at number 7, and again we're still on page 406, but when I look at number 7, 3x plus 3y, I need to ask myself this. What's the greatest thing as a term they have in common? Let me deal with numbers first. I see 3 and 3. What's the greatest number they have in common? Obviously 3. Okay, they have 3 in common. Now, I look at their variables. I see an x with this one. I have no x over here. I see a y with this one, but I have no y here, so there's no variable that's a part of the term that is the greatest common factor. It is 3 and 3 alone. Now, what I'm going to do is divide all of this by my greatest common factor, which is 3. And what that's going to do is give me information to put inside of a parentheses that then is going to be multiplied by the number that I find out here. So what's 3x divided by 3? Of course, just x. Plus, keep your signs, what's 3y divided by 3? Obviously, y. And so when I factor 3x plus 3y, I have 3, then inside of a parentheses, x plus y, and understood this is being multiplied or as a factor of everything that's inside of that parentheses. And if I wanted, I could check it, and we're not going to do this, guys, with each one, but just to give an example, if I want to make sure I've done it correctly, we'll just go ahead and distribute and see if I get back to where I started. What's 3 times x? 3x. Plus, what's 3 times y? 3y. Look familiar? That's where we began. And so I know that this 3 open parentheses x plus y must be the correct answer. Okay, let's do it with number 8. ax plus ay. What do these two terms, separated by a plus sign, what do these two terms have in common? I see an a here, I see an a there. They're both to the first power. Therefore, what they have in common is an a. Now, I'm going to use that information to put these two terms in parentheses. I see an x here. I see no x there. I see a y here. I see no y there. A is all that they have in common. So what I'm going to do is divide this entire expression by a. What is ax divided by a? Just x. keep your signs, plus what's AY divided by A? Well, A1 minus A1 is going to give you A to the 0 power, which is 1. We don't express that. So all with which I'm left, just like the x over here, AY divided by A is simply Y. And so I have A, open parentheses, x plus Y. In other words, A is a factor or being combined by multiplication to everything inside of that parentheses, x plus Y. I could go through and check it if I need to, but no, Mike, I'm not going to do that. But I can if I want to, but we understand the process by this point. Okay, let's do number 9 together on page 406. 8x minus 32y. Now when I have numbers that are written in front of variables, I want to deal with the numbers first. So let's just ignore the variables right now. 8 and 32. What is common, the greatest common factor between 8 and 32 as a number? The first thing to do is ask yourself, will the smallest number go into the other numbers, in this case the only other one that's found? Will 8 go into 32? Yes, well, we know 8 goes into 8. So the largest number we're going to use outside of parentheses is going to be the number 8. Now what about variables? Are there any commonalities found there? There's an x here, no x here. There's a y here, no y there. So there are no variables that are in common. All that's in common is the number. And so since it's 8, what I'm going to do is divide this entire thing by 8. And what is 8x? What is 8x divided by 8? Of course, you just have an x left over. Keep your sign. In this case, it's not an addition sign. This time it's a minus. Keep that minus. The signs are important. What is 32y divided by 8? First things first. Just take care of the numbers. What's 32 divided by 8? 8 goes into 32 4 times, evenly. Okay? And you have what left over with which you do not deal? A y. And so 32y divided by 8 is 4y. And so what I have is 8, open parentheses, x minus 4y, close parentheses, or in other words, 8 multiplied by all that's found in the parentheses. You can multiply all that out and you come right back here where you started and you know that you did things the correct way. That's factored. Alright, let's look at numbers 16 through 18. These have a little bit more meat to them. What is in common between 21x cubed minus 6x squared minus 3? Well, I start with the numbers first. And this time it's not 2, okay? It's not 2 numbers that I'm using, but it's all 3 numbers that I'm using. So here's what I'm going to do. What does 21, 6, and 3 have in common? What do they, I should say, have in common? Take the smallest number and ask yourself, does 3 go into all of the others, which in this case there are only 2 others? Does 3 go into 6? Yes. Does 3 go into 21? Yes. So my greatest common factor as a number is going to be the number 3. Okay? And what I'm going to do, and allow me if you will, give me just a sec here, I'm actually going to erase that. I don't want it to get confusing. I want to keep this same format we've been doing. And so what I'm going to do is I'm going to put 3 over here and open my parentheses. And I'm going to divide all of this by my greatest common factor, 3, to find out what goes inside of the parentheses. Alright, what's 21 divided by 3? 21 divided by 3 is 7. Okay, look, I couldn't do any variables in common because this term doesn't have a variable, and that's why we didn't even discuss it on this one like we had been on the others. And so 21x cubed divided by 3 is 7, but look, I don't do anything without x cubed, so I just rewrite it. Keep your signs, minus, what is 6 divided by 3? 6 divided by 3 is 2. I do nothing with the variable and its exponent because I'm not dividing by any variable or exponent. And so I just rewrite x squared. And lastly, I keep my sign, minus, and then I don't have to think about negative numbers, okay? What's 3 divided by 3? 3 divided by 3 is 1. And so 21x cubed minus 6x squared minus 3 factored is 3, open parentheses, 7x cubed minus 2x squared minus 1. Okay, let's do another one right here. What do these three terms have in common? All right, let me look at them. My smallest one is a 6, and so I'm going to ask myself, does 6 go into 48? The answer is yes. That's a product of it. Does 6 go into 24? Yes. And so I can use 6, I know, number-wise, as my greatest common factor. Now, can I use any variables? This one has one, that one has one, but this term, the third one, does not have a variable. And so I can't use any variables for my greatest common factor on this particular one. And so what I'm going to do is divide this entire thing by my greatest common factor that I found. What is 6 divided by 6? Do the numbers first. 6 divided by 6 is 1. Well, I don't even write that. I do nothing with the a squared, and so it's understood 1a squared, but we don't put a 1 in front of it, and that's why I've left the number off. We know that. What is 48 divided by 6? 48 divided by 6, keep your sign plus, is 8. I do nothing with the variable, so I just rewrite my variable a. I keep my sign. This next sign is going to be a minus. Okay, what's 24 divided by 6? 6 goes into 24 4 times. I close my parentheses. And so factored, this big long polynomial, is 6, open parentheses, a squared plus 8a minus 4, close parentheses. All right, let's do one more on these, and then once more I'll erase, and we'll get just a little bit more practice in on a final thing. This is all simply review from what we did on that Monday. Okay, so I look at this one. 5x plus 7y minus 11z. This is number 18. Let me look at these numbers. The smallest one, 5, does that go into 7? No. Does that go into 11 evenly? No. But this is a prime number and I can't break that down anymore. Okay, so there's no number that's in common. What about variables? I have an x here, but no x there, no x there. I have a y here, but no y and no y. I have a z here, but no z and no z. So I have no numbers in common, and I have no letters in common. So what does that tell me? Guys, this is another one of those that as an answer is simply prime, meaning you can't break that down any more than what it's already found. Alright, that's these. Let's do just a few more and then we're going to quit for the day. Alright guys, last leg. You've done a great job. Thanks for staying with me. This one's going to be a little lengthier than what most of the videos are. I just really want to make sure that we've had good practice in and we understand this first lesson very well, because we're going to build on it. And remember, this is the reason I started teaching math when I was asked to do it at Tri-County Christian School. I love this stuff. Factoring is a blast. And whether you recognize it yet or not, it is a blast. And you are going to enjoy it. So, here we are, number 29. Let's do 6, and these are going to go a lot faster than what you think. Okay, the first 2 we're going to take a little bit more time, but the last 4 we're going to scream through them. Easy stuff. Alright, for this first one, 29. 7a to the 5th minus 84a cubed. Make sure you're taking good notes. Plus 21a. I look at the smallest number, okay, 7, and will it go into each of these others? Does 7 go into 84? Yes. Does 7 go into 21? Yes. Therefore, my greatest common factor as a number is, I'm going to write it over here, 7. Now, be careful, because look, I have an a to the 5th, and this term I have an a cubed, and this term I have an a. Do they all have the same letter or variable? Yes. And so that's also going to be a part of the greatest common factor, 7a. I can only take a to the first power though, because that's the largest that all 3 share in common. A to the first, so 7a to the first power. And so what I'm going to do for this one is divide the entire thing by what I'm factoring out. 7a. All right, just look at the numbers first. What's 7 divided by 7? That's 1. I'm not going to express that because I have a variable here and I don't write the number 1 in front of my variable. A to the 5th divided by, you guys like when I do this, so a to the 1st. And remember, when I divide variables with exponents, I actually end up subtracting those exponents. All right, so I'm going to have a to what power? 5 minus 1 is going to give me a to the 4th power. Okay, keep your signs. Minus. What is 84 divided by 7? 7 goes into 84 12 times. Okay, what's a to the 3rd divided by a to the 1st? Subtract the exponents. 3 minus 1 gives you a to the 2nd, or a squared. All right, and then I'm going to have plus, keep my sign. What's 21 divided by 7? 7 goes into 21 3 times. 3 times. And I have a to the 1st divided by a to the 1st, which gives me a to the 0 power, which is 1, but 21 times 1, or after we divide it, 3 times 1 is just 1, so we just leave it as 3, and we close parentheses. And I could FOIL this back out and make sure I have it correct. I'm not going to do it to save time because it has been done correctly. But 7a is factored out, and in parentheses is all these terms divided by 7a. All right, this one's a little bit easier, number 30. I'm going to factor out what I can. First of all, do I have any numbers that I can factor out? Well, no, there's an imaginary 1 in front of all of them, and we don't even write that because it's so meaningless, really. And so I'm not going to write that out, but I look at my letters, or my variables. I keep confusing those variables and exponents. But I look at variables here, and I have all the same variable, and that is the variable what? X. Okay? And what's the greatest exponent that they have in common? Well, this one, the 4th one's only to the 1st power, and so I can't go any higher than that because that's going to be the highest that they all have in common. So I factor out an x, open parentheses. In other words, I divide the entire expression by x. This is x to the 1st power. X to the 5th divided by x to the 1st, 5 minus 1 gives me x to the 4th. X to the 3rd divided by x to the 1st, 3 minus 1 gives me, plus, keep my sign, x squared. Okay, keep my sign, minus, that's coming next. X squared divided by x1, 2 minus 1 is x to the 1st, and so I just write it as x. I've run out of space here, but I'm going to finish it right down here. Keep my sign, plus. All right, what is x to the 1st divided by x to the 1st? 1 minus 1 is 0. X to the 0 power is what? Don't say 0. We always get confused by that. Any number to the 0 power is not 0, but it's 1 no matter what it is. And I close my parentheses. Okay, I hope all of that makes sense. Now, let's finish quickly on 31 through 34. These don't take very long. This big long expression, x times in parentheses, x minus 2, close parentheses, plus 8, open parentheses, x minus 2, close parentheses. To write this as a factor, there's a shortcut, guys, and we're really going to build on this the next several lessons. All that I'm going to do is just rewrite one of what's common in these parentheses. I have 2 in parentheses x minus 2's, and so I'm just going to use one of these, x minus 2, and then look, I have outside the parentheses x and a positive 8. And so what I'm going to do is combine those just as they're found outside of the parentheses but inside of parentheses. And what this is just a shortcut, and you can multiply all this out and combine like terms and see that it's exactly the same thing anyway. Use one of what's common in the parentheses, in this case x minus 2, and then use the two terms outside of the parentheses, but just write them inside of a parentheses. And so this big long expression is simply in parentheses x minus 2, and then in the second parentheses, x plus 8. Now, using that information, let's look up here to number 32. 4y in parentheses times, in other words, 2y minus 1, close parentheses, minus 3, and in parentheses, 2y minus 1. Guys, look, what's common in the parentheses? Just rewrite as one of those, 2y minus 1, and then write inside of a new parentheses the information outside of the parentheses. In this case, it's 4y minus 3. So just use one of what's common in the parentheses, 2y minus 1, then take what's outside the parentheses and put them in a second one, and all that's going to end up being foiled together and will come out as a shortcut to the same answer as what that is. It's the most simplified way of writing it. Look at this one, 33. 5 in parentheses b plus c plus a in parentheses b plus c. What's common in my parentheses? B plus c, and so I'm going to write that once, okay? And then I take what's outside of my parentheses, and I write that inside the second parentheses. 5 and plus a. Let's do it once more for number 34. 6x times, in parentheses, y minus z, close parentheses, minus 7 times, in parentheses, 7 minus z. Guys, what's in common in the parentheses? Y minus z, so I just write that in one set of parentheses, not twice as it is here. I'm doing a shortcut, and then I take what's outside of the parentheses, and I put that inside of them to be multiplied by what was common or found twice, y minus z. And that's in simplified, factored format. All right, that's all that I have for today. If you need to, feel free to look back and watch more of the video. If any of it's confusing, please contact me during school hours, approximately 8 to 11:30ish, okay? I'll be available. You can contact me any other time too. I can't guarantee I'll be available because I work at my other job pretty much when I'm not at school. So, but I will get back to you as soon as I can. Email me. Feel free to Facebook chat me. You can text me or call me as long as your parents are okay with your doing that. And we can talk about it, and we can work on this. We can have some one-on-one tutoring if you need to. But I have all the confidence in the world in you guys. I know you're going to do great. Thanks so much for your effort in it. The other lessons won't be as long. I don't even think they're going to be as hard. But I'm looking forward to factoring together. Thanks, guys.